the limits of a function. We know that function means it's a mathematical relation between the variables. We have two different types of variables, x and y, or other letters also can be adopted. And these variables can be defined as two types, which means independent variable and dependent variable. Independent variable means it is free from the changes, and dependent variable means it is changes according to the another letter. So the function can be written as y equal to f of x, which means here we have x is the independent term and y is the dependent term. In this case, we can have the limits of the function. The limits means it is the very, very close value of the actual value of the function, which means we have two types of limits here, left hand limits and right hand limits. If these two limits are equal, we can say the function has limits or limits exist. If these two limits are not equal, we have to say function limits does not exist, which means we have LHL and RHL. If these are equal values, we can say function has limits. Function has limit. If these are not equal, which means LHL not equal to RHL, we can say function does not have any limits, which means we can written as limit does not exist. Limit does not exist. These are two important theorems to study in this topic. So we will check with an example for this theorem. So the LHL in mathematical form we can write like this. LHL is limit x tends to a f of x minus. This minus indicates left hand limit, and RHL we can mention like this: x tends to a plus f of x. If this value, as I mentioned before, if these values are equal, x tends to a, f of x is a particular value. This is a theorem we are going to do here. Actually, we have different methods to follow or to illustrate or finding the limits. Now, I'm using the first beginning method. It is called like functional value method. We are using here the functional value table. How we are writing that functional value table means we are taking two different types of values for the independent term, like left hand value and right hand value. So we will take one example to illustrate this theorem. Here, evaluate f of x equal to x plus 1 if x less than 2 and x square minus 4 if x greater than or equal to 2. Why it is coming like this means it is a composite function which having different two domains. X less than 2 indicates the left domain and x square minus 4 indicating right domain. So we have to evaluate limit of the function, which means we can write like this: limit x tends to 2 f of x. In this case, we have to calculate two limits, left hand limits and right hand limits. Here we have two tables. It is evaluating for left hand limits and right hand limits. You please consider this table here. We can take this LHL and we can take from here RHL. What is the LHL means? We are taking the value, it is x tends to 2. So we are taking LHL very close and less than 2. The values are very close and less than 2. You can see the column of this table. It is indicating 1.9, 1.99, 1.999. It is very close to number 2 but less than 2. So if you are considering RHL value, here x I am taking this value 2.1, 2.01, 2.001, which means it is very close the number 2, but it is almost greater than 2. Then I am applying this value in the function, but we have to consider here two type of function here. As it is I mentioned here, it is the composite type of function. So we have f of x equal to x plus 1 for x less than 2 and f of x equal to x square minus 4 for x greater than or equal to 2. So I have written here f of x equal to x plus 1 for LHL and f of x equal to x square minus 4 for RHL. So we have to evaluate in this function, we have to evaluate the value of x here. For example, we are calculating 1.9 plus 1 like that. So the value will get 2.9. Again, I am going for the next iteration. So it is 1.99. If you are putting in the function, you will get 2.99. Again, I am going for the next iteration also, 1.999. It is if I evaluate this function f of x plus 1, so I will get 2.999. From the LHL, if you look this column, which means the value, functional valued column, you will get approximately, you will get 2.9, 2.99, 2.999 means approximately equal to, or strictly we can say equal to 3. So limit x tends to 2 minus f of x. 2 minus f of x means LHL. So 2 minus f of x equal to 3. Like that, we are considering the value here, RHL. So we have the values 2.1 f of x. We have to consider here x square minus 4, as I told you before. So here we will get the value 0.41. If you consider the value x equal to 2.01, you will get the value 0.041. Again, if you are considering the value 2.001, you will get the value from the function 0.0041. So if you look on the table, RHL table, it is for the value function column. If you are looking here, you will get approximately 0.41 here, 0.041 and 0.0041, which means it is approximately equal to number 0. So we can write here a limit x tends to 2 plus f of x, which means 2 plus indicating that is RHL, so 2 plus indicating f of x equal to 0. So we have to consider these two values here, 3 and 0. We know that by looking these two values, we know that limit x tends to 2 minus f of x not equal to limit x tends to 2 plus f of x. So these are not equal, so we can conclude limit does not exist. So we can say here limit does not exist. Thank you.